Hey there, it's me again. It's Saad. Now I'm really excited because it's gonna be a really fun topic I'm about to do. I've decided that instead of doing just the Heisenberg uncertainty principle, or just the Schrödinger's cat, I've decided to do both of these and a third, because they're so intercorrelated with each other. I'm gonna do Heisenberg's uncertainty principle, the double-slit experiment, and this one, Schrodinger's cat. Well, here we go into this fun video into quantum. Okay, the first one I'm gonna do is the double slit experiment. Okay, so first let's not do it quantum, but we'll do it normally. Let's say there is a blackboard, and that blackboard, you take it, and there is kind of this box, but there is one slit in the middle, and you take a gun and start shooting marbles everywhere on the first board. Some of them will pass through. What is the pattern? If, let's say, one passes through and it hits here, the next one passes through here, 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 here. What is the pattern that forms? Well, one slit, like that, like so. But let's now say you took two slits and you started firing marbles at them again. Well, in that case, there will be two slits formed on the board. And that happens. So, well, let's go on. Okay, now let's say that you just kind of, there's water and you started sending waves. Oops. So it's kind of going like this, like this, like this, and hitting the double slits. What happens is when this wave hits the double slits, one wave comes out of this and like that. But the thing is, waves are different. When they combine, they start making interference patterns. So where the two troves meet, they become brighter, and they kind of like start doing this and this, so that there are many large places where two whale peaks meet. This happens, but when it hits the whiteboard, you can see that there's some over here. They come in stripes because of the interference. You can see everywhere two troves meet and two peaks meet. There's one over here, over here, over here. Lots of them, and they form this interference pattern. So once these waves hit, if let's say they made marks, not marks, like as in marks, but so they would have kind of this pattern. Now you'll notice that when it was a marble, it has mass, so it made those two slits with the double slit. But these are waves, so they made this interference pattern. But now let's go quantum. Let's say now you started firing electrons at this. What pattern forms? Well, yes, only one slit formed, one mark formed. But if you fire electrons at a double slit, what happens? Wait, what? Electrons have mass like particles, yet they created interference patterns like waves. What happens? Have electrons lost their marbles? Unlike waves, electrons have nothing to interfere with. But wait, then physicists thought maybe electrons were bouncing into each other, and that's why they formed these many slits. So they were interfering with one another. So to try and get this back, they decided to fire these electrons one by one so that they had nothing to interfere with. Now, physicists thought, now surely there should be two patterns. But no, once again, they were an interference pattern. But physicists were baffled. What was the interference with? The physicists were forced to accept what really happened. They realized that when these electrons crashed into, well, this is a reality side. When they crashed into the barrier, they went through both the barriers at once. One particle goes through both barriers at once, went through the other side, and literally interfered with itself. One particle went through both gates and literally had interference with itself and formed 10 slits, or a pattern of slits. Physicists' mind exploded. Literally. They had to clean up later on. Anyways, because this is called superposition in physics, because it's going in two places at once. You'll see that this is similar to Schrödinger's cat experiment. It wasn't really an experiment, by the way. It was a thought experiment, the other one. This was a real experiment. So they decided to place a camera to actually have a look at which of the two it went through. Because they couldn't accept this, that it's going through both at once. So they decided to see, what does it look like? A particle becoming a wave, splitting into two and making it interference. Oh yeah, I almost forgot. This actually has a further maths, because if you do, this was all the real part, but if you do the maths of what just happened, there are 4 different ways. Let's call this slit A and slit B. The math said that all 4 of these were true at the same time. One electron went through A and B at the same time, or one electron went through neither A nor B at the same time. One electron, this is all the same electron. Let's call this electron S for my name. S went through A and B simultaneously. S also went through neither A nor B. S also went through only A, and S also went through only B, all at the same time for the same electron. Yeah, they really had to clean up. Nor did their minds explode, but their skulls exploded with it. I know. So they decided, as I was saying, to put a camera. Let me clean this up. Yeah. Okay, this is gonna take. Let me just narrate meanwhile. So what happens is they decided, because all of these, they decided that they'll just put a monitor and see which side did electron S go through, because they wanted to see, did it actually go through both? Like, what would that look like? And what happened next was the most strange and even spooky thing. When I heard about this, I got so baffled. Like, I actually got terrified, positively terrified. What happens is they started firing one after the other once again. You know what? I'll just change this to object eraser. Should have just done this before. Oh, yes, that's better. Oh, okay, that's better. So what they did now was they took this, and when an electron came through, they noticed that this time this electron actually only went through one of the slits. S came through this slit, Y came through this slit, but then they're like, and when they looked up, guess what happened? On the measuring, only two slits were formed. What? The electron started behaving like a marble when it was being watched, and started behaving like a wave again when it was not being watched. So it's as if the electron knew, like watching. The electron stopped behaving like a wave when it was being watched, like electrons are alive and they knew they were being watched. One of the biggest puzzles in quantum history. This forced physicists to admit that an electron can behave both like a particle and a wave. Okay, now we move on to the famous thought experiment. Schrödinger's cat. This famous guy named Schrödinger, he imagined, let's say, oh, I have that on, I need to change that. He said, let's say I have to delete this now. Anyways, let's say there is this cat. Not a very good cat. Meow. Ha. He looks more like Pinocchio. Tail. Let's say just this cat, okay? A monstrous cat too. And it's put in a box with a radioactive substance. Now, let's say the box is sealed, you cannot look in, and it's soundproof, so you have no idea. Now this radioactive substance has a 50% chance of deteriorating, and it would cast lots of radioactive waves to kill the cat instantly. But 50% chance nothing will happen and the cat is still alive at the end of an hour. Now, let's say 1 hour is over. What is the cat's state just before you open the box? Common sense tells you that the cat is either alive or dead, but Schrödinger, he thought that because of the double-slit experiment too, he thought that this cat is actually both alive and dead at the same time. That is, until you open the box. This idea is really, really absurd, but it, again, is the concept of superposition. Does this word ring a bell? Yep. Back in the double-slit experiment when the electron went through both slits at once. This is just a proof of that, technically. Or that is more like just a proof of this. Schrödinger was one of the people who helped actually start quantum physics. this was a relatively short topic. Now, let's begin our third and final topic. Heisenberg's uncertainty uncertainty principle. All this principle says is that an electron can be, oh no, not again, why? And now let me delete this. Go away, come on. Okay, there we go. An electron can either be a particle or a wave. I've already mentioned this, but this has implications. Remember my previous video, in which the latest one is, what was it? The quantum one. Remember that one? I told you exists in orbitals which have clouds of probability. Because let's say there's a particle. You know exactly where the particle is, but you do not know what is its velocity and which way is it going. A wave, you know which way it's going and how fast it's going by how fast the wave tips and wave things move, but you do not know its exact position, because a wave does not have exact position, and a particle does not have speed or velocity. That's literally Heisenberg's uncertainty principle. It has you can go further, because you can actually join those two, but if you try and, let's say, because if there's a wave top and there's another wave top, those two join to make a really big wave. But if there's a wave top and a wave bottom, those two join to just make a straight line. Let's say there's this wave and you add another wave. It kind of adds up to become, if you add enough waves, then you'll have soon enough, you'll have one gigantic wave. This is kind of your area. So this is where your particle's area is, and the velocity is how fast it is moving. But you can see that the particle can be anywhere within this range. So that's Heisenberg's uncertainty principle. And if you get it really, 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 really thin, then that'll be more certain, but the wave's velocity will be less certain. So this is literally Heisenberg's uncertainty principle. An electron, I'll just write it down. An electron is either a wave or a particle. Okay. Let's just say that's or a particle. Okay, next. Let's say waves have velocity but no exact location. Okay, how do I enter this? Yes, here we go. And particles have location but no velocity. How do I enter this now? Enter. Ooh, how did I enter last time? I don't know. Enter. Okay. Let me just continue writing. Oops. Aha, there we go. Therefore, you can never predict an electron's future path. Aha, there we go. Since you need both location and velocity to calculate calculate an object's future path. Okay, this is literally Heisenberg's uncertainty principle, and that's the end of the video. See you next time.